we are, I believe, recording now. Yep. So again, just quickly do fill out this, this forum, game design research, top-down visual design on the Moodle page, along with the code basics that we'll be going through this term, or this week, excuse me. Yeah, anything, I don't know if Nick or Miles, if you have anything you want to add on that, or if you want to just want me to start jumping in on some coding stuff.
That sounds great. And then that actually fits well. I was just going to say a couple of words about the design process. If we want to do that first or afterwards, I'm okay with either way. So how do you want to do it? If you want to jump.
Maybe do first, if you're up for it. Now might be a good time. Yeah.
Sure. Okay, great. So yeah, I can share my screen here in a moment. Yeah. So I just wanted to say a couple of words about doing the visual design for your game. So there's nothing due for this except for the forum part that David described. So, and that fits nicely into doing the visual design, since many of us here are coming at this kind of from a visual design level because we're artists and creatives in that way. And so I just wanted to say a couple words about that process. So, and I'll start off just by sharing I'll start with sharing my screen here. So yeah, with, are you guys seeing my desktop, all this stuff now?
Yeah.
Okay, great. So this is my friend Adam Calloway. So one of the things about this is kind of funny. I was going through this. I was thinking about collaboration. And so Adam and I have been collaborating on some stuff over the years. And so he's more of the programmer and I'm more of the artist, but this is just some kind of fun little photos. I missed that collaboration part of it. So there he is. That's kind of his Chuck D phase there. So like that. So anyway, and that was just one of the reasons I wanted to show that is that it kind of fits into this idea of starting a folder. And so this is our game is called World with 2 O's in it. That's our kind of working title. And so, I just wanted to say a couple things. Let me back up one more step, where as you're starting to consider or think about making something, one of the things I want to put out there is the idea of questioning the good. Like, question what you think about as good. Start with what you think about as good. And like David was saying, start off with that thing of like, there's probably something that's like a little kind of impulse in the back of your head or something about wanting to make a game, which has brought you to this point, or we've all had that impulse, when you see something good, there's a part of you that says like, oh, I should make that. Like, I want to make that. I want to do that. And that's a really, really, really important impulse. And that's like this little kind of flame, that you have to kind of keep together and really take care of, because that can easily get blown out. So you want to kind of take care of that. But one of the ways you can do that is by questioning the good. So a lot of times, Fallout, Grand Theft Auto, or Halo or whatever, and we're like, oh man, this is so cool, like I want to make that, and then you sit down and you're just by yourself and it's like, like what, how do I do that? And so, because we think, oh, that's good, but that isn't necessarily what's going to be good for you, especially in the starting phase and the conceptualizing phase. So question the idea of what's good, question the idea of what's going to be important, and let yourself admit that you don't know what that's going to be. You don't know what the game that you're making is going to require of you. It doesn't have to be what has been good for other games. That's just one of the things I want to throw out there. So the main thing I wanted to talk about, which ties in exactly with what David was talking about today, is you want to do 2 things, I think, when you're starting out your research. 3 things. You want to give your game a title, and that can be a working title, because I think the act of naming something is really, really, really powerful. It really makes it's the first thing. It's like you're summoning this new entity out of the ground, almost out of yourself. And I think that naming it is such an important part of it. So let yourself give your project a name, a title. And then you can make a little folder, on your desktop here. So world, down here. And I've got the world art, and that's what I was going to look at today. And the second thing, so after you give your thing a title and make a little folder for it, and you can make a physical folder for it too, if you're more analog kind of person. It doesn't have to just be digital. But the second thing is to start collecting what we call reference. And so this is actually a very advanced technique. This is a technique that you can start today, like David is saying, and that image that you start with would be your first reference. But we use this all the way up into our 400 level classes and all the way up into professional practice. This is just kind of a done thing. And your references become anything that you're thinking about that may or may not have a connection to the game. If you think about it in connection to the game, it has a connection. So you don't have to worry about, like I'm making this kind of really simple game, but I'm thinking about like, oil paintings, huge oil paintings, altarpieces from the 15th century. Fine, throw them in there, or I'm thinking about like rugby or something. Throw it in there. That's fine. Images, anything that inspires you, that's relevant. So start collecting that stuff. And that will probably include, like David was saying, games, images of games, because that's going to be something that you're going to be thinking about naturally, but it's not limited to that. So I always have here a reference folder that I just say references. And basically every project I do has that references. And to simplify it, I think the third thing I was going to say, so thing one is title, thing two is references, and thing three is concepts, which are your own drawings. So the two main folders I start off with are references and concepts. References is anything that I didn't really do explicitly, and concepts is anything that I've done myself. Anything that I'm making is a concept, and anything that I'm looking at is a reference. So that's about it. And I'll just show you kind of randomly. I'll just pull up some images, or this is in my concept art folder. And so this is a pretty advanced concept that's pretty modular, but these are some early, concepts that I'm thinking about. And these are all digital. Like this one is more scratched out. These are some notes. So it could be notes. But something like this, I think, is almost more important at this phase. Like something that is super scratchy, rough. It's not like, hey, look at me, I'm a great artist. It's not that to me is not what this early phase is about. This early phase can really be about just the roughest, scrappiest, scritchiest, scruffiest stuff, you can think about. So keeping it really, open-ended at this point. Oh yeah, it's a quick shout out to doing paper types. That's another thing you can start doing. So it can be totally lo-fi. I mean, so this is just, don't worry about Photoshop or Krita or whatever, just get out your pencil and paper and action stuff out, and then just keep track of it. This is a pretty nice prototype, but yeah. So scritchy, scratchy, rough stuff. It doesn't have to be super worked out, and simple, basic ideas. So that's about it. Title, references, concepts. So title, references, concepts. Reference is stuff by other people. Concepts by you. Oh, I'm sorry. I just wanted to show these really quick. So I'll just throw some of these up. This is what's in my reference folder, kind of like what David was just talking about. So it's just anything that I was looking at in reference to other games. So this is all stuff done by other people. So I'm looking at interfaces, because all this stuff as an artist, you've got to design all this stuff. None of this stuff is just made. You have to to make it. So I'm looking at interfaces. I'm looking at Tetris. Tetris is a great example. If you don't think about yourself as an artist, fine. There you go. Board games, good old StarCraft, Spore, SMES, more board games. So, yeah, kind of really simple stuff, complicated stuff. Yeah. So that's it, I think. So just be starting that process. And what David described is really like the first step. You can just take a little bit out of your folder, out of what you're starting to do. But this is a very important, fun part of the process, especially since we're all stuck in our little caves. This is a good time to start dreaming big. Cool.
Yeah.
I'll stop sharing.
Nice. Yeah. Thanks, Miles.
Sure. Yeah, but if anyone has any questions about that.
Are we thinking Dropbox as being the collaboration tool for a shared folder?
Well, I
think
think
where are we at with that?
If we need to share materials or want to share materials, I think probably the best is I would think would be Google Drive, because it's supported by everyone has a Google Drive account.
Okay.
Whereas Dropbox has to be, you have to sign up for it and all that.
Right. Okay.
Yeah. Nice. Okay. Well, let's move over to start thinking about some of the coding stuff. And as I sort of mentioned already, and then I think Miles is pointing in the direction of this, looking at all that great stuff, is really seeing, like, trying to start thinking about the connections that are going to happen, where the coding that we're starting to do again is going to start feeling pretty rudimentary and sort of removed from that interesting visual language and those cool things that we might come up with as ideas. But just understand that it's just a couple of steps to start making the connection between the code that we're doing and then the code that you're going to be wanting to apply to games. Hopefully,
just one more thing is if you're having questions while David's going over this stuff again, like, just throw them into the chat. We're here. We'll be looking at that as David's talking. Rad's on it. He's super fast, good with this. Mm-hmm. Nick and I will be watching too. So yeah, just go ahead or if you guys want to answer some of the questions too, jump in on the chat. So it's great. All right.
Yeah. Awesome. Great. So the things that I'm going to want to start showing now are going to be things primarily going forward. So it might be a few little review things that we do at the beginning. But then primarily it's going to be building on and adding some new elements in. But it's not a huge step this time around. And things are really sort of cumulative. So they will build on some of the foundations that we already built for ourselves this last week. So the first thing that I want to really focus on is starting to, we did some simple manipulation of numbers and putting numbers into variables and adding them and displaying them last week. And the first thing that I want to do is start extending that slightly, which is giving a little bit of control to the computer, which is through making the computer generate random numbers. So as of right now, everything sort of always will run the same way because in the code that we've done, we sort of like set a variable equal to some number, and then we add it to another number, and of course the result's always going to be the same. So now we're going to add a little bit of extension to that idea, which is randomness. And randomness is really, it's a fairly simple thing to start getting to happen. But at the same time, it's really a powerful tool because it allows decisions to start happening outside of your control. And that is something that at first it's like, wait, but I want to be in control of everything. Well, probably you don't. Probably you want some other things to be able to start making some choices for you. Like, you don't want to have to tell, like, if you're going to have 1,000 like warrior beings in your field of play, you're not going to want to have to tell each one of those warrior beings exactly where it is at any given time, or maybe even where they start. You want to be able to allow the computer to leverage its decision-making ability. And of course, it's like decision-making ability in quotations. These things right now are just very simple sorts of things. And randomness really is one of those key things that allows a computer to be able to simulate making decisions in a human-like way. We normally don't think of as the human as being a random decision maker, but that you think about creativity. Usually, the creative element is the thing that it diverges from expectation, right? And so, having a computer be able to make random decisions is the first step towards a computer being able to make decisions that seem like creative decisions, rather than just like, I make 1,000 things. Okay, I'm going to make 1,000 things all on top of each other. That may make sense to a computer, but that wouldn't be the decision that we would come to first as humans. So anyway, enough said about it. But randomness is a sort of a big thread and an important larger topic in starting to move towards things like minimal artificial intelligence and getting the computer to do more interesting things. So how do we do it? The very simplest way to start is going to be leveraging a library of tools inside of JavaScript. And a library is simply a collection of functions or pre-built code that you can access to be able to do functions that are and things that are made available by that library. So so math is a built-in library, and it's math dot and then the name of whatever function you want to call. And so right now the one we're going to be working with is random. So math.random is a function. So we have the parentheses at the end of it. And this math, just beware, it's a capital M for math. And this is going to call that function of a math.random. It's going to call a random number generator within JavaScript. But we need a little bit more than this to be able to see it. So let's take this, and I'm just going to put that inside of a document.write. And we should get now our document to write a random number. So it did that, great. So there's, this is putting it directly into our document.write. You could do that in the console.log and view it there. And you'll notice that what did it generate for us? It generated a number 0.951153, etc. A long list of decimals here. And this is a number that we'll call a floating point number. A floating point number is a number that has a decimal and end values after that decimal. That would be different from an integer that we'll use in a lot of times. And an integer would be something that's truncated at that decimal point. So 0 would be an integer, 500, 512 are all integers, negative 7,002 integers. But when we have the decimals in there, we call those floating point numbers. And in a lot of cases, those can be used interchangeably, but there are certain cases when we really want to use things just as integers. Let's say like you want to make a random choice of between 5 things, and you want the computer to generate a number between 0 and 4. You want those to be 0, 1, 2, 3, and 4. You don't want those to be 1.75, and because it'll be harder for it to tell, like, well, is that, like, which one of those are we going to be using? So in any case, a little bit ahead of myself, but there'll be times when we want to use these floating point numbers and times when we want to use integers. So another way that we could do the same thing here would be to set the variable equal, or set a variable equal to a math.random. So we say my num equals math.random. We're not displaying it yet, but we can then say document.write, and I'm going to give us a carriage return first, just so that we have a space between it, and then document.write num. So now I should have 2 lines that are displaying here, 2 separate random numbers. We see that they're different. The only thing really that's different about the way that we created it is one is that I called it directly inside this document.write function. This other one, I assigned the result of this math.random call So it's a call to the math.random function, and it returned a value. We'll look at returning values a little bit later, but we talked a little bit about it. So it's going to return a value, and we're going to assign that value to the value of variable num. And then we simply display it. So let's see, any questions so far on that, or any things that not really happening? Okay, yeah, good. Looks like no other real questions that are jumping out directly related to that. Good. So so again, key things, remember math.random. So math is the library. Dot in this case is saying to go into the math library and find a function and execute a function named random. And then we have to have these parentheses after it because that's what says we're doing a function now, do that function. And then it goes and generates a random number and then returns it. So the range of random numbers are, you might be able to guess here, if we just did a bunch more of these, they're all going to be in the same range. And it's going to be between 0 and 1. Oops, what happened? There we go. So they're all going to be between 0 and 1. I just saved the code. So it re-executed them, 2 new numbers, but they're both between 0 and 1. Those are both on the high end, but that's what it is. So oftentimes that can be okay. We can make decisions based on things within that. We could say, hey, if a number is above 0.5, do one thing. If it's below it, do something else. We can do that kind of conditionals that we'll get into in a moment. But sometimes you want to have a wider range. Like you say, hey, I want to, I'm going to have this be a jump, and I want to decide it's going to be a random jump. Is it going to jump 5 pixels, or is it going to jump 100 pixels? And I don't know how it's going to happen. So you might want to have a wider range of values than simply between 0 and 1. So the easiest way to do that is you still use always the generation is at that between 0 and 1 level, but then you scale up or you scale down or you move or shift those values so that they become useful for you in whatever you want, whatever application you have. So for example, if I were to do a new new thing here, I'm going to do it the same way. Var num equals math.random. And I'm going to comment out these other lines, so we're just seeing the one that I'm working on. Now, if I wanted to simply make it a larger scale, if you start out between 0 and 1, but I want to make it now a range between 0 and 100, it's simply me multiplying it by 100. So multiplication is the asterisk and times 100, and put our end of line semicolon there, and then I'll document .write this num, and we will see now. Okay, great. Now I have a number that is should be between 0 and 100. It still has that decimal value on it, though. You'll see, and that's fine for right now. So each time, let's say if I save it, sometimes it re-engages, sometimes not. Let's see, is it going to do it? That's one thing that's a little bit trickier with CodePen, is sometimes telling it to exactly when you want it to re-instantiate. If I just type in a different number here, retype that number, it should redo it for me. Come on. If not, you can just believe me. There we go. Okay, finally got it to give us a new number. But this will be in a range between 0 and 100. Okay, so that could simply, then if you want it between 0 and 1,000, make that times 1,000. If you want to choose a number between 0 and 10, make it 0 and 10. Any number that you want to do. What that's doing is, the term I use is scaling. And you have a number that's in the small range, and I'm scaling it up to a larger range. Or another term that's commonly used is mapping. So you're mapping a value range that was between 0 and 1, and you're stretching it to map it out to a range between 0 and 10, or 0 and 100, 0 and 1,000, whatever it is. Great. So another thing that you might often want to be able to do like this, so I'm going to leave this at between 0 and 100, is that sometimes you don't want to choose 0. Or let's say you wanted to choose, I want to choose a number that's between 50 and 100. Or let's say between 100 and 200. So let's do that one. I want to generate a random number between 100 and 200. So what I've done already is I've generated a number between 0 and 100. So if we think of 100 to 200, what's the difference? Well, 200 minus 100 is 100. So I have a range of numbers that's going to be 100 wide there. So that's what you generate first. I did that here, 100 values, or a range of 100, and then simply shift it by addition. So I can then add 100 to it. So if I do this, I generate a number between 0 and 1, then I multiply that by 100, so now I'm between 0 and 100, then I'm adding 100 to it. So if I generated 0, it's now going to be 100, so 0 plus 100. If I generated 100, it's going to be added 100, it's now going to be 200. So the result of this is a number that should be between 100 and 200. And let me again try and prompt it to do it again here for us. There we go. So there we go. Now it's should be again 118. Great. It's between 100 and 200 going on like that. Does that make sense? So my process is here thinking about what is the range of numbers that you need. So let's do another one just quickly by our in our heads for a second. If we wanted to generate a number between 25 and 50, what would we do? So what is the range of numbers between 25 and 50?
You'd want the range to be like multiply by 25 and then add 25?
Yeah, nice, exactly. So we'd be going, we have a number between, so 25 to 50 is going to be, if you do 50 minus 25, that's 25. So that tells us we would need to have a range of numbers that is going to be 25. So I'd multiply it by 25, and then I would add 25 to shift it over. So we then had a number that was between 0 and 25, add 25 to it, so now that becomes between 25 and 50. And let me get our line break in here. Oops. And we should then see that on separate lines. Now the second line, come on back. What happened? It disappeared on me.
You just need a D in front of, you lost the D in front of document there.
Document, oh, thank you.
Aha.
Good catch. Great, okay, good. So now this second number should be between 25 and 50. Yeah, exactly. So thinking about the total range of values that you need and then shifting it into the location that you need them to be. So if I need between, if I have between 25 and 50, that's 25. And so instead I wanted it to be between 50 and 75, I would do the same code here, but just say plus 50 instead of plus 25. And then now we're starting between 50 and 75 is our range that we can generate those. Okay, so it'll take a little bit of playing around with for you to sort of feel a little bit comfortable with it, but that's a really useful thing. And it happens so much that you want to generate a random number between two values. And so much so that actually the challenge assignment for this week, the last one based on functions, is for you to write a function encapsulated that you'll be able to tell it two values, which is like a minimum and a maximum, and then write a function that's going to be able to generate a random number that's between those two, between a minimum and a maximum. So it'll be a little bit of a stretch to fix that, but yeah, go ahead.
Why is the randomness a kind of math question instead of just implementing like a lower number and a higher number and a symbol in between them to mean randomness? Why is the coding written in a way that it's doing math instead of saying how we write it out, usually with a minus sign in between? Wait, I just answered.
That's a great question, actually. Yeah, that's actually a perfect question. I can take that as a non-programmer,
sure,
non-native programmer.
Yeah.
This is actually the kind of question that I'm glad I showed those pictures of Adam. So as an artist, kind of native, when I'm working with that question comes up all the time. I'm like, why is this happening? Like, why is this, that doesn't make any sense to me. And it, like, why is there this really complicated process to generate a random number? Is that the question?
That is
Basic.
indeed. Yeah.
Yeah. And so, and I think that's such a cool, that's a great question, and like, keep asking that question, because I think the answer is it's because that's the way, because you're working with a computer. And the more closely we are controlling the computer, the more we have to speak the computer's language. So, and as artists, we tend to work with kind of stuff that's higher up or further down, depending on which way you want to look at it that way. That's been designed for us so that it speaks more of a human language. So, like in Photoshop, when I take a paintbrush and I make a line, you know what I mean? And so that's, as an artist, I get that. But as a programmer, if I want to create a program in which someone can take a paintbrush and paint a line, I have to go down and talk. I have to go downstairs quite a ways to talk to the computer to define what that is. And so going into math.random, it's really funny. If you were to talk to a computer scientist, they could do like a week-long seminar on the problem of randomness in computers. You know what I mean? So it's really funny. As an artist, I'd be like, I don't care. Like, just give me a random number. I need to roll a 6-sided die. You know what I mean? So these are great questions, because this is where we're getting into it. We're really crossing over our fields here, so that as an artist, I'm like, hey, give me a random number between 1 and 6. That's good enough for me. I don't care how you get it. Just give it to me. But as we get more into working with programming, it's like, oh, that's actually an interesting question. So I don't know if that answers that.
It just sounds evil all the way through.
Oh,
But I will live with the math.
Yeah.
Make no mistake, it is. So,
Yeah. But I think that
you can,
one, like a sort of a computer science term that I think that describes what Miles is describing is this idea of like lower level versus higher level programming languages. And so even within a programming language, sometimes you'll have languages that are like low level would be things that are like, the lowest level might be like machine language, where it's really coded in zeros and ones, and the computer sees a series of zeros and ones down at its chorus, like at its most basic structure, and that's what it interprets. But humans, that's a very difficult thing to understand. There's like 2 people in the world, I don't know, not many people that really understand, can sort of see the zeros and ones and see much meaning in them. But if you go up to higher level programming languages, you get more abstractions, which become more useful for us to sort of understand, oh, okay, so there's this thing that generates a random number, and it's between this range that I don't really care about, 0 and 1, but I can make that work for my purposes. There might be other programming languages, and there are, that might have a random function that you just say random 7, 15, and it will give you out a random number between 7 and 15. So that's a slightly higher level programming language, and it makes certain things easier, but at the same time, actually, it will also, there can be some downsides to them as well. Not so much in this, but it might take more memory. The programs might run slower than a program that's written in a lower level language, and there might be certain things that, because the program was written in a certain way, it might reduce the certain types of choices that you might be able to make. And that's something where it might not be as obvious in that example, but it's like going back to the Photoshop thing. Someone, a group of people developed Photoshop, and there are a set of tools that it allows you to do things with. But there are things that people might want to be able to do that Photoshop can't do. And that doesn't mean you can't do them. It just means that the program was written in such a way that it prioritizes certain types of behavior. So anyway, this is starting to get a little bit tangential with it. But for our purposes, we start with a number that's between 0 and 1, and then we use some math to scale it up, shift it around, and get it into the forms that we need it to be.
There's a quick question.
Yeah. Mm-hmm.
It looks like there's multiple ways to accomplish the same thing in coding. When you get to a more professional level, is there like one standard on how to do things? Or is that why there's like 5 different kinds of code for accomplishing the same goal?
Yeah, I mean, I'll answer quickly. I mean, and then maybe others have takes. I think there are definitely multiple strategies to do things, and that there are ultimately, if they all work, they're more or less it's fine. I think eventually there's that people get into nitpicky ideas about what works the most, like whatever the most best version of something. And sometimes it comes down to, like there are these threads that you'll see on like Stack Overflow is a great site where you can, for researching, if you have errors when you're working on code, that's a great place that someone has probably already had that error and solved it. But you follow down some of the comments and you get into really minutia of like, well, the absolute best way to do it is this way because it takes 2 less characters and therefore it's going to optimize your code by this amount. And so it can get pretty rarefied. But for the most part, I think that there's some basic syntax that people will tend to follow. And it's really, a lot of it in my mind is really just about clarity. If you can do things in the way that are the most clear to you, and that you could imagine that someone else could come in and look at your code and be able to clearly see what you're doing, that's the goal, I think, at this point. And so for example, in this class, we'll prioritize having variables that are a little bit more explicit in their descriptive capabilities. So like I might have a variable that is like character height, and that's fine, and it's perfectly legit in terms of programming. But down the road, people might say, oh, that should really just be like var ch or var c or something like that can be done in a really shorthand way, because it's slightly more efficient. But for our purposes, if you're going to have a big long program, remembering that C was character height versus D was something else gets cumbersome and unwieldy. So for our purposes, clarity, I think, is really the key. And so it's a combination of being clear with the code and then also commenting. Like do a comment and say this variable is going to hold the value for the character's height. I mean, it's pretty obvious in that example. I might not need to do that, but to be somewhat explicit for your own sake. So when you go back into the mess of code and say, oh, that's where I need to go in and do something. So, yeah.
And I think it's just to even go back to that question. That's great, David. Is like I think one way I would sum it up is that once you start talking to programmers, if you talk to 5 different programmers, they're going to tell you 5 different things about what the best way is. So I think like the more you go into coding, the more you're going to get the argument over what's the best way to do this, or what language should we use, or how should we do this. And just to repeat, I mean, like David talked about at the very beginning of the class, like using a library. And so libraries are ways that you can create functions that do things that do come up all the time. So we're going to be seeing that in the next week or 2. So the way you make a library is by using raw code. You know what I mean? Like you use the more you go, the more you're using these kind of really stuff that's really down in the basement, down in the cellar, like only the goblins down there that never get out and see the sun. That's the deeper you go, the more you get into that kind of stuff. So we're going deeper.
Nice. So I'm going to move on a little bit here, but just a slight extension and then we'll move away from the random and start moving into some conditionals and good stuff like that. But do keep all the questions coming. These are great. So the next thing that most commonly people want to be able to do with randomness is to be able to choose, as I mentioned, the difference between a floating point number and an integer. So you'll often want to be able to convert to go back and forth or between those, usually going from something that generated something with decimals and then get it so that it's now giving you just an integer. So I want to do an example of that. So let's make a third line here. I'll just go ahead and make something that's like this. And I'm going to say that I'm going to say float. I'm going to give a variable named float for my floating point number. And it's going to be a random number between, we'll just make this easy, between 0 and 100. And we're going to just write that. Okay. Oops. And then what I want to do below it, I'll comment out this other stuff so we can clear which ones we're looking at right now. Then I want to be able to convert this number into something that is an integer. So I'm going to do that down here. Var int, I'm going to call it an int, equals, we're going to go into the math library again. And the one that there's a few different ways to do this, but this is the one that we most commonly have ended up using in here, is one called math.floor. And I'll write it in here and then describe what it does in a second. And it is a way of rounding. It's just sort of a simple way of rounding down. So it's always going to take a number. There we go. And it is going to drop it to the next lowest integer. So what it does is, in this case, we did it. I created a floating point number between 0 and 100. And then we printed that here. It's 56.37. And then I assigned a new variable called int that I'm standing in for integer. And I did this function math.floor. And I did that function on the value of the float that we generated. So that 56.37107 went in here. And math.floor takes whatever goes into it, and it's going to drop off, basically think of it cutting off all of the decimals. And we see that it returned 56. So this is different than a little bit of the rounding that happens, you know, like if it's above 0.5, it will go up, and if it's below, it goes down. This one just always drops down to the next neighbor down. And it's useful for a lot of ways, or for a lot of the type of rounding that we encounter. There are other versions of that, but math.floor, just thinking of it dropping down to the next, like to the floor, is how it's achieving the rounding that it's doing. So that did that. So let me see here as an example. Now, if we wanted to do it, let me just say, let's do this between 0 and 10 now. So it gave us a number 1.38 and it dropped down to 1. If I were to do it again, let's see if it will refresh it for me. Yep, 7.41 goes down to 7. And do it one last time, maybe. Maybe not. But the thing to note here is that what is the actual range that it's going to generate for me? Well, it's going to generate a number that will be at this level. It will be between 0. So it could theoretically generate 0.000, and it could generate all the way up to, I believe it would be, it's 0.99999, so it would be 9.99, which, when then we convert to integers, will be actually 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So it will never give you 10. So if you notice this, if you're doing this kind of scaling and it says times 10, the actual range that I'm usually going to be choosing from is 0 to 9. And remember that if you start counting with 0, a lot of times in coding, you're really starting counting with 0. That's going to actually still be 10 members. So if we said, you know, go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's 9 plus 0, or plus 0 as a member, so that's 10 total choices that you have. So that's something that will come across a lot as well. It's like, I want to choose between 5 different things, okay, you say math.random times 5 and do the same thing, but remember that the choice is actually going to be between 0, 1, 2, 3, or 4. But those are still 5 elements that you choose from. So always just remember, often count from 0, and that will come up again as we move into next week and start working with for loops and arrays and things like that. Deal with that a lot. Awesome. So any questions that coming up that I should address relationship to math.floor? Let me do it one other way, just as a reiteration. But yeah, go ahead if you got a question.
I was just curious if it was absolutely necessary to have var float in order to get var int.
Okay, good. Yeah, no, you can kind of abbreviate things or condense them in a way. So for example, I could do this if really all I wanted was a one-time random number that was in an integer in a certain range. I can do it all encapsulated in one line. I'll do that right now. But before I do it, the reason you might want to do this is if later in the code, for some reason, you wanted to retain access to the floating point number. It's like if all I want is the integer and move on, no, you wouldn't have to. But anytime you set up a separate variable, that's going to give you access to that variable later on in code. You can go back to float and find what that value was as differentiated from the variable int. So in this case, it's not a big deal, but again, as moving forward, that might be useful. Here, what we could do is I could just say, I could actually do here all in one thing, document.write. It'll get a little nested here, things nested in other things. I'm going to do math.random, and I'm going to then times it by I'll do this into 1,000. And then, am I on a good, I need to do a line break here. Okay, so I'm now on the last line there. So math.random times 1,000 gives me an integer between 0 and 1,000. But then I can put that whole thing in math.floor in the parentheses right in there. And then now we get an integer that comes out 596. So this does everything we just did all in one place. It generates a random number. It scales it up to be between 0 and 1,000. It rounds it down to its next lowest integer, and then it writes it to the document. So it's more condensed, but I wouldn't have access to any of these things after the fact. So I wouldn't even actually get the value of this 596 from anything because it hasn't been assigned to a variable. It was displayed, sure. If the only thing you wanted to do was display it, great. But if you wanted that number to affect anything in your code, you'd need it to be applied to a variable, which you could do like this. So one last way here, var new num equals math.floor of math.random times 1,000. So now I could get that new num, whatever its value is, and use it later on in my code. So yeah, good question. Yeah, you can condense these things, and it's really just a matter of this, like the scope of where you want to have access to those numbers later on. Cool. So let's see here. So let's move on to the next thing here, which is going to we'll still be using a lot of this. And actually, let me use the portion that I did right up here. So I'm going to use this int that I created. So we know that we have an integer that's between 0 and 10 now. And I want to start doing things based on what that value is. And this is what's called a conditional. So a conditional is something that is going to do one thing given a certain situation, and it's going to do another thing maybe given another situation. And there's various ways of branching based on that. And the most basic form of this is an if statement. So if, and I'm going to do this in pseudocode here for a second. If and by pseudocode meaning I'm kind of writing it using some words that aren't true code, but give you the structural idea here. So if some condition is true, do some code, or do this code. Okay, so this is kind of the basic structure of an if statement. So if, and then in parentheses, if some condition is true, so it's going to test some condition, and if it's true, it's going to execute the code that is in the code block that follows it, and that's defined by the curly braces. So let's see here. I'll just put in the basic one using that int. So if we say if int is equal to 4, then do document.write it is 4. Okay, so when this condition in here will only execute if the integer equals 4. Notice that I used a double equal sign. That's something that's, we talked about the single equals as being really assigning a value to something. So up here with a single equals, the value that was generated here is assigned to this variable. So whatever here goes over to the left. Here with the double equals, it's really the question, is it equal to? Like, is int equal to 4? And then if this comes back true as a true statement, it is going to do this coding here. It's document.write it is 4. Currently, it's not working because it's not doing that because I'm getting 3 as my result. So let me just, I'm going to try this once or twice, and then if not, so that was a 2, so no. And then let me try it one more time. And then if not, I'm going to do something that's more likely to be true. So let's generate between 0 and 5 here. Nope, it gave me 4. So it's not working, but if we said instead, is something less than 4, now we should see that it's less than 4. Great. So it gave me 2, rounded down, it says it's less than 4. So that structure is really the key thing. It's pretty simple. If you remember the basic parts of it, that you have this if, then you have in parentheses the conditional, the thing that you're going to test, or the test condition. And then in between the curly braces, you have the code block. And the code block could be a single line. It could be multiple lines of code that are in there. Lots of different things could happen. So some common comparators, so some ways to compare are, let's see, we'll see these in the examples later on. So you can do less than, you can do greater than, you can go do equal to, you can do less than or equal to, and you can do greater than or equal to. And all of those are the most common ones. Oh, there's one more that's a really useful one as well. Not equal to. So not equal to is exclamation point equal sign. So that would be another one that would most likely work here. So let me do one again with our same number. If int is not equal to 4, say, or not equal to 1, say it is not equal to 1. Okay, so this time we got 1, so it is less than 4, and it is equal to 1, so this statement is not true, so that didn't execute. If we did it again and save it, maybe we'll get a different number than 1. Yep, Great. It is less than 4, that's true, and it's not equal to 1, that is also true. So it's just important to remember that this executes only when this statement is true in here. All right, so let's move forward a little bit more. So there are also some other situations that you can expand this, which is, so this is what you'd either call an if statement or an if-then statement. So this is the if, and this is the then portion. That's what you do in that case. And the extension of that, which you may have heard of, is like an if-then-else statement or an if-else statement. So let me just do that on one that we already have here. So now we say if the integer is not equal to 1, we say it's not equal to 1. We can just right below it, if we use the keyword else and then do another curly brackets, this will execute in the sort of the opposite case. So if int is not equal to 1, it will do this code. But in the case that this is not true, it will do the code that's down here. So let me revert, well, I guess we'll do it still like that. Document dot write, it is equal to 1 in there. So now, if it is 1, it will do one thing, and if it's not 1, it will do the other thing. Let me see if I can get it to give me that value. So it's not equal to 1. Let me prompt our choice down to between 0 and 1. It's not working. I'll have to force it here. So I'm just going to cheat by say int equals 1. Now it says it's less than 4, and it is equal to 1 because I made it so. Okay, so what happened here, it said int is 1, it comes into here, it says if int is not equal to 1, it says no, that's not true because it is equal to 1, so it didn't do this code, but then there it sees it an else, because okay, I have to do the else, so I come into here and wrote that instead. Okay, hopefully I'm not making that more complicated than it is. The logic of it, just like from language, is pretty straightforward, right? It's like, if this is true, do this, else or otherwise, do this other thing. Nice. So another thing that can happen is that we have special conditions or special data types that can be used in conditionals that are called Booleans. And now Booleans are really useful for conditionals. And this is something that a Boolean is a fancy word for a data type that has only 2 states. And the most common ways of talking about that are true or false, or sometimes if you deal with it numerically, it's 0 and then non-zero. Any number that's not 0 versus a number that's 0. It's basically like on-off sorts of states. So if we were to think of that here, we could have a variable called, let's see, sunny today, and it gets true. And you see, I didn't put this in parentheses or in quotation marks because true is actually a known thing. It's a keyword, like true or false is something that JavaScript knows. And you can tell that in CodePen because it colored it this yellow. If I said true F, does it do? No, I guess it didn't recode it. So never mind, I won't, don't complete my sentence. Var sunny today equals true. Then if we want in our, to do a conditional based on this, we could say, I'm just gonna make another thing here. If sunny today, we could write if sunny today equals true, and then we write document.write I'm happy. That works. But there's another version that works, which is great for using if you're using Booleans, which is just you'd get rid of the equals true, and you say, if sunny today. And at first it seems awkward and it seems like it's missing something, but if we remember that it's testing, a conditional is always testing, is the statement that's in here true? Is this statement in here true? And so when we did one of these other ones, int less than 4, it went off and evaluated integer and compared it to 4 and said, is it less than 4? True, yes it is. And it came back true. Down here, sunny today, it does the same thing. It goes off and looks at sunny today and finds that sunny today actually evaluates to true because that's what its value was. So you can just say simply, if sunny today, and then do this, and you see that it's working. It says I'm happy over here. And the opposite of that is you use the not, which is that exclamation. So if not sunny today, document.write, I'm sad. So if I change my sunny today to be false, we should see it now. This does not evaluate as true. This does. So not true, it comes back and it says I'm sad. Okay, so that's a shortcut there. Yeah, go ahead.
So I would imagine the fastest way to write that would probably be the if sunny today, document.write, I'm happy, but then else I'm sad.
Yeah, yep, exactly. Okay. That would be the most condensed way to do that. But I just wanted to show that you can put this structure with this exclamation point and then the variable that's being tested to say not sunny today. So yeah, but either of those could have an else statement that would evaluate the other condition. And that's going to be really common with a Boolean because with a Boolean, you know that you have two states. You have one state when it's true and another state when it's false. Whereas when we're evaluating the integer, like an integer between 0 and 10, it might have 10 different cases in there and you only care about one of them, or maybe you care about all of them. But with a Boolean, it's really an either or situation. Yeah, great. Okay, so that's Booleans, that's comparators actually are in there as well. And then really the last coding thing that I wanted to talk about today is working with functions that return values. And so we had talked a bit about functions last week, and I actually had in some of the examples on the CodePen, I think it talked about, well, actually in the helpful hints, it talked a little bit about returning values, but I don't think we really talked about it in class. And you weren't asked to do anything with it. So let's look at that a little bit and we'll see if we can do that here in relationship to some of the stuff that we've been doing. So when you create a function, let's see. Let me call on Miles or Nick or someone. What's a function that we might be able to do here? Because I don't have a set one that I wanted to do. What's something that we could do that might return something useful to us? Or something at least humorous.
Yeah, so let's say
we could write a function that simplified the random number generating process.
Okay.
Where you passed it two arguments in a more human fashion, maybe. I don't know.
Okay. Great.
It might be too complicated, but give it a shot.
No, that's good. And that's sort of the one we're looking for you to do. So this will be a good sort of demonstration. So we're not just throwing you to the wolves, so to speak. Yeah. Okay. So let's write this here. So as we're generating
code wolves.
Code wolves. Yeah. So random. I'm going to call this random in range. So we want to be able to give a random number that's in a range of numbers. And if you remember a function, so when you're defining a function, the most basic way of defining a function is like that. And then in here you'd say, you're going to do something in here. I'm putting it in a comment, so it's not actually doing something. You use the keyword function. You give it a name that's arbitrary. So this is a name that you've defined. The only thing is just not have it be a name that's being used somewhere else in your code for something else, just to be clear. You give it these parentheses and then these curly braces. But you can also pass it, well, let me start there. So just a refresher on functions. So if we have, we could start with document.write, and I'm going to say num, or I'll call it random num. There we go. And I'm going to say var random gets math.random, just like that. Okay, so this is the sort of review of everything that we've done and remembering about functions. So I'm going to comment out all of this for now. And just for your notes, I will, this code pen that I'm working on is week 2 lecture demos, and it's getting saved. And I'll clean it up in some way that's sort of all working at once, and I'll have it posted. It will already be in my on my code pen. So if I know a couple of people were following me, you can find it that way. But I will also post it as notes in the Moodle page under week 2. So you can always come back and look at that. Okay, so remember we have the function, we have to define it, and then we have to call the function. So we say random, I'm going to say random in range, in my parentheses, like that. And that simply calls my function. Okay, so that's a very basic thing that we did last time, and it goes in and does our math.random. Great. Okay, so now the first step of something that we want to be able to do, and this is the part that's new, is that we want to be able to return a value. And what that means is that you have a function that does something, and then it brings that value back to you in a way that you can use somewhere else. That's just like that idea of having variables that you can then address later on in your code that we were talking about before. To do that, it's very simply we say return random in this case. So we created a variable random, and we set it equal to something. We wrote it up here, but we don't even actually have to do that. I'm going to comment that part out right now. And then we return random. And by return, it means send that value outside of the function and send it somewhere, and then we can use it. So now we see that when I call this function, it doesn't do anything that we can see because it's not writing it somewhere. But we could, if we said document.write, and then put that in parentheses, it should work, which it did. And the reason is it goes in and executes this, and it returns a value, and it's going to write the value that was returned. Another way of doing that would be like we've always done, is set it equal to a var and say var num gets the value that is returned from the function random in range, like that. And then we could document.write our num, and it would do the same thing. Okay. So before I move on to actually making the range part of it work, which isn't happening yet, so I know that's not happening. But are there questions about that key function or defining functions, the idea of a return, and then accessing the value that was returned from a function? Is that more or less clear?
I was thinking about it. Oh, go ahead.
Okay. So when you return the random variable, you still have to call on the function before you can use that again. Like, what would stop you from just doing document.write random after, like, outside of the function?
Awesome question. Great. And that is another sort of topic. So that deals with something that's called variable scope, which is where in your code knows what variables. And so far, and I talked a little bit about this in my section last week, but we didn't talk about it as a lecture. So some people may have heard that term. A variable scope, the scope that we've been using so far is what's called a global scope. So if I come up in my code and just say var name gets David, that is that is what's called a global variable. It's going to be accessible from anywhere in my code. So if inside of my function, I came in and said and did something and asked for name, it's going to know what that is. But a variable that's defined within a smaller scope, like within a function, is going to only be you're only going to be aware of it within that function unless you somehow send it outside of that. So let me look really quickly and show you on here. So if we go to week 1 coding videos and tutorials, it's in here. Is my sound cutting it out, or you guys okay?
You
I'm
sound
okay.
fine. You sound fine to
Okay.
me.
Okay,
Yeah.
good. I was just getting a little bit of clutter or clicky feedback.
Yeah.
So let me find it in here. There's these slides that you can chunk through, which have some great background and all this stuff. And somewhere in here is, there we go, variable scope. And I just really wanted to show this picture here. And you can see, oh, like that. So this is showing like, it's like a Venn diagram, and things that are shared and things that are subsets of that. So global means everywhere in your code it's accessible. You might have a function that's defined, and it's only going to have access to things that are global or defined there. And a function could be defined within a function, so you could have nested functions. And so you can see in here, like this blue variable, whatever that is, variable blue, is accessible to function 2, but it's not going to be available to anything else unless you explicitly like send that value out somewhere. Same here, the greens are just going to be available here. They're not going to be available globally. This yellow is not going to be available over to this function over here. It's only in here. But these global ones are going to be available everywhere. So that's kind of the thing that we're talking about when we talk about variable scope. We talk about local variables versus global variables.
What would be some examples of variables that would be available globally versus locally?
Great. So in practice here, so an example is, and it's really just where you define the variable defines whether it's a global or a local. And so here, this var name David, or var name is now a global variable. It's accessible to anything in my code here, including inside of the function here. And this is one way to think about it, well, is that if you go next to the function here, you can click on the little triangle there. It's kind of faint, but you can see that it collapses everything down. And so you can imagine that anything in here is a part of that function. And so any variable that I define in here, like random, is going to be a local function. It's local to, or excuse me, a local variable, and it's local to this function that I've created in here. And one way that you could sort of visualize that is by, if I close that down, you see that the rest of the code can't see that variable. It doesn't have access to that variable. So random, if I came out here and said document.write random, I should get an error, which I do. Good, let me see how it comes up. It says random is not defined. And then as beginning coders, we're saying, but I defined random, right? I did it right here, it's defined, but it's not defined in the scope that we're looking for. So it's not defined at this global scope so that, or here it is, so that this part of code has access to it. If I wrote down here name, it's not going to have an error. It's going to say, sure, great, I have access to that. It's defined for me because it's in the same scope. Yeah, so now let's see, we have this random is not accessible outside. It is a local variable, but by returning it, the value that it contained can be used somewhere. It's a little bit different than I still don't have access to random explicitly itself, but I can get the value that was held by that there. So that's why we can, or how we can do this. Great, so let me try now to make this work in the way that we want it to, in a quick version anyway. So if we want to have random in a range, we need to be able to give it the range, and we need to give it a minimum and a maximum. So another thing that we can do with the functions is we can give it values in that are parameters, and these are in the parentheses. And parameters are things that are going to be used as local variables to that function, and values can be passed to it when in the function call. So I'm setting up what's going to be a min and a max, so that I'm going to be able to say, I want to, as my test case, I want to generate a number that's between 50 and 100. So what I want to be able to do is say 50, 100 when I call my function down here. Yeah, that's my goal. So I want to be able to do that. My thought process here is always figure out what's the range. So the range is going to be, anyone want to venture a guess? What's the range of this? So we know like between 50 and 100 is going to be what's that range?
50.
50, yep, good. And how did you calculate that?
100 minus 50.
Awesome, great. So in order for us to calculate 100 minus 50, 100 is going to be max, and 50 is going to be the min. Those things come in, so this 50 comes in and takes the place or fills in this local variable of min. So I'm going to times, so ignore the times for a minute. I'm going to do max minus min. So that is going to be 100 minus 50, gives us that range. And then we times that by our random value, which was 0 to 1. So that now gives us a value that's between 0 and 50, which is a good step. And then what do we need to do to offset it so that it's now between 50 and 100?
Add 50.
Nice, thanks. Yep, add 50. So we've calculated our range between, so 100 minus 50 is going to be 50. We do 50 times the math.random, so we get it to be equal to, that is going to be a number between 0 and 100, or excuse me, 0 and 50. And then we're going to need to add 50, so we add that to shift it, but I don't want to put 50 because if we change our numbers, that's going to change. So we're going to add our minimum. And now the only thing we have to really be careful of here is we need to make sure that our order of operations is happening the way we want it, and that there's all the parentheses are happening in the right way. I think I've cut something out so that you have a start parentheses and end parentheses for everything. So I want to do this first, then I want to do that, then I want to multiply it by my math.random, and then I want to add my minimum to it. And so I'm doing this so that I can enforce the order of operations that I want it to do. Like, do I want it to multiply first, then add, or add, then multiply? I'm kind of using the parentheses as a way to do that. Okay, so let's take a look. I'm going to clean this up here. So that's looking like it's happening. Let's do one last step to it, which is to make it a integer, just because those are nicer to look at sometimes. So I'm going to say random equals math.floor of random. Awesome, great. It seems that worked. So this is my way of rounding down, and this is a bunch of stuff in here, all in this one little function. It's like everything we did today, except for conditionals. I'm using this math.floor as a way to round down, and I'm rounding down random, and I'm setting it equal to its same value, so it's just sort of overriding its value with its integer version now. So that's a little bit of a sort of a trick. That's like that thing that we saw last week of num gets num plus 1. Like it doesn't work in math, but it works in code because you're assigning a new value to that variable. That's what's happening here with this line of math.floor. So let me test it. I'm going to do a completely different range, and I'm going to say between 100 and 300. And let's see if it gives me a number. 134. Great. What if I want one number between 1 and 3? 1. Okay, awesome. Nice. So questions on that? That's kind of our summary example. Or observations or anything else that's useful there.
Just to throw one thing out there, I think that we covered like a ton of stuff. Like I remember years ago, a CS student saying like, wow, you guys just covered, like, we spent like a quarter on this stuff. So we're throwing a lot of stuff out there. So we're not expecting you to necessarily just have remembered all of this stuff and be able to use it fluently. That it's really important to back up a little bit and think about the logic of this. That what we've kind of introduced today is that, like, you know, last week we introduced, oh, you can create your own variables, you can create your own functions. Like, great. Now we're introducing the idea that, like, you can create random numbers. Awesome. And you can create conditionals that check whether or not something has happened, whether something is true or false. That's the main thing to take away from today. And the syntax of it, all gritty little detail about like, why is it math.floor, parentheses, math.random dot, you know, blah, blah, blah. That's going to come more natural the more that you do it. And personally, I mean, I just copied and pasted like a mother until I got the feel for it. And then it's like, oh yeah, I remember it. But like, don't expect yourself just to snap this stuff off the top of your head for a while. You know, like, do it, repeat it, test it, try to write your own versions of this. And it's very satisfying once you start to get the hang of it. But like, it takes a little while to do it. So really think about the overall, like, oh, I can do conditionals. Like if then, that's cool. Oh, I can do random numbers. Oh, I can combine these things. That's cool too. But I don't remember how to do it. Let me go back and check the notes that we've got in these exercises.
Nice. Yeah. Great. Yeah, I think that's a great overview of the key things, and you know, this is exactly going to be what you're going to step through on the code basics for this week. So if we just look at those just for a second, just to see the sort of the topics, so you see that they should be all familiar after today. We have, so the first one is random numbers. Some of these you'll notice they have in the comments, they'll say like part 1, part 2, part 3, asking you to do a few different little parts, so a few different versions of random numbers. All the stuff that we sort of showed today, generate a random number, be able to get it into a different range, be able to drop it down to an integer rather than a floating point number. Some conditionals, Booleans, the true false stuff, comparators, which is just really more of a demo of using the other types of comparators, equals to, not equals to, greater than, less than, greater than or equal to, that kind of stuff. And then functions for, which is the last thing about returning function or functions that return values, and really trying to do just what we did. So we have all the code up there to be able to make a function that generates a random number within a range. So it's there, so don't panic. You will get the answer, but it'd probably be the best for you to try and tackle that on your own. So like starting from, okay, I remember some parts of it, but let's see if I can make that function on my own from my memory from the lecture, and then go back and compare to the notes that are here, so that you a balance of that sort of like copy paste notice what's there, what's working, but also trying to struggle a little bit, knowing that you can always copy and paste the answer and grab it from these notes. So yeah, that's the goal for this week. All those 1 through 5, and then make sure and also do that game design research, a little post here in the forum, and stay in touch via the Discord. It's great to see stuff getting posted there and questions, comments flying on there as well. I don't know if there's anything else on the chat that we need to wrap up on. I haven't been following that as clearly.
Looks good. I think.
Okay.
Did we miss anything? If speak up if we did.
Yeah. Any other questions?
And then yeah, Discord's great. I mean, we're definitely looking at the Discord. People are checking that out. So if you have questions that came up after this, that's great. And really, you're just practicing. Let yourself.
Yeah.
You're not under the cosh to. We're not expecting you to kind of have this all memorized by 2:00 this afternoon. So like you're really just practice and play. This is like it's a play pen, if you will, this code pen. So
nice. I will post the recorded lecture up under week 2, as well as the chat. We'll get that up there as well. And we'll be seeing you guys on Wednesday, if not before, during our regular time. Awesome.
Yeah, feel free to check out, and then if you want to hang out, we'll hang out here for a couple minutes. So, but if you guys are ready to go out and sit outside and have some fun, go ahead. You're free to go. Cool.